This video is going to show you how to change a mixed number into an improper fraction. Okay, so when we are adding and subtracting, multiplying and dividing fractions, we like to work with improper fractions rather than mixed numbers. So if you ever see a mixed number in your question, the very first thing you want to do is change it into an improper fraction. So here's an example of a mixed number. 2 3/4. It's a mixed number because it has both whole numbers and a fraction. We want to change this into a fraction that has a numerator that is larger than the denominator. The way that we do this is we take our denominator and we multiply it by our whole number, and then we take that number and we add the numerator. So here we add 4 times 2 equals 8 plus 3, which equals 11. That becomes my new numerator, and I keep my same denominator of 4. So 2 3/4 is the same as saying 11 out of 4. And we know that's true because if I have pies that I cut into quarters, okay, my denominator is 4, a quarter, so I'm going to cut my pies into quarters. And if I have 2 full pies and then 3/4 of another pie, then I have 11 quarters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 fourths, 11 pieces of pie that are cut into fourths. So that's another way that you can change an a mixed number into an improper fraction is by drawing a picture. Okay, use your denominator as how many pieces each whole is cut into, and then color in what we have here and then count the number of pieces that you have. Next, we're going to look at how we can take an improper fraction and change it into a mixed number. So going backwards, here we have an improper fraction of 10/7. Our numerator is larger than our denominator, so that tells us that we have something that is greater than 1 whole. 1 whole in this case would be 7 out of 7, but we have 10 out of 7, so we have more than a whole. So the way that we change this to a mixed number is we take our denominator and we ask ourselves, how many times does our denominator divide into our numerator evenly? And if we are figuring this one out, we say, how many times does 7 go into 10 evenly? Well, it only goes 1 time evenly. That's going to be my whole number of my mixed fraction. If I continue this division question, 7 goes into 10 1 time evenly, which is 7. 1 times 7 is 7. If we subtract, we know that we have 3 left over. When we divide 7 into 10, it goes 1 time evenly, but we have 3 left over. That becomes my new numerator. And I keep my same denominator of 7. So 10/7 becomes 1 3/7. It goes into 10 1 time evenly, but there's 3 pieces left over. And then I keep my same denominator that I started with, 7. So that's how to change an improper fraction to a mixed number. If we try that with a negative number, it works the same way. So we ask, how many times does 5 go into 12? We can just ignore the negative for now. 5 goes into 12 2 times evenly. 5 times 2 is 10. And we have 2 left over. So 5 goes into 12 2 times evenly with 2 left over, and I keep my same denominator. The last thing I need to do here is remember that I started with a negative fraction, so I am going to preserve that negative in my mixed number. So we just kind of ignore the negative while we switch from the improper fraction to the mixed number, and then we have to remember to put it back on the end. Okay, because if this is a negative fraction, my mixed number also needs to be negative still. Next, we are going to look at how to add fractions with unlike denominators. If fractions already have like denominators, such as, I'll just do over here on the side, 1/2 plus 3/2, then we know my answer is just 4/2. My denominator stays the same, and I add my numerators, 1 plus 3, 4/2. Of course, we can reduce this to just 2. But we are going to now look at how we add fractions if the denominators are not already the same. So I'm going to use the example 7/8 plus negative 2/5. So the first thing I want to do is find a common denominator. And one way that I can do this is by simply multiplying my two denominators together. And that will give me a common denominator. So we have to actually do a lot of multiplication before we can finally add these fractions. Because what we're doing is we're taking these two fractions and we're changing them into an equivalent fraction that has the same denominator. So I've already determined that if I multiply 8 and 5, I can get a new denominator of 40 for each of these fractions. But I want to now change this fraction, 7/8, into an equal fraction that has a denominator of 40. And that means whatever I did to this denominator to get from 8 to 40, I need to also do to my numerator to change the numerator as well. If I change my denominator, I have to change the numerator by the same factor. Now I know that in order to get from 8 to 40, I multiplied by 5 because I just multiplied these together. So that means I also need to multiply my 7 by 5. Okay, I multiplied both of these numbers by 5. 8 times 5 gave me 40. Now I multiply my 7 by 5 and I get 35. And you'll notice if you're having trouble figuring out what it is you need to multiply by, it's right here. I multiply the 7 by 5. So now I need to change my second fraction. Now this fraction, I did not multiply this one by 5. 5 times 5 gives me 25, not 40. So here I multiply this fraction by 8, the one on the opposite side. So if I multiplied my denominator by 8, 5 times 8 gives me 40. I also need to multiply my numerator by 8 in order to keep this fraction equal with the one above it. So negative 2 times 8 gives me negative 16. Okay. So now we just have to add 35 plus a negative 16. And again, I keep my same denominator of 40, just like I did over here where I already had a common denominator. I kept my denominator and I just added my numerators. So here I have kept my denominators and I'm now going to add my numerators. And this is where some people find it a little bit tricky because my numerator is a negative number. So I'm saying 35 plus a negative 16, which is really the same as saying 35 take away 16. If we're talking about our number line, we start at 35. If we're adding a negative number, it means we're going to the left on our number line. We're going towards 0. So we're actually subtracting 35 take away 16. Okay, and if we work that out, 15 take away 6 is 9. 2 take away 1 is 1. So I end up with 19 out of 40 would be my answer there. Let's try another adding question, but this time we're going to have a mixed number. So we have 1 1/3 plus 2/5. Now remember I had mentioned whenever you have a mixed number, the first thing you need to do is change it into an improper fraction. So we're not going to worry yet about finding common denominators. The first thing we want to do is just change this mixed number into an improper fraction. So if we look back at how we did that up here, we multiply our denominator by our whole number, and then we add the numerator to get a new numerator, and we keep our same denominator. So let's go back to this question. We're going to do the same thing. 3 times 1 gives me 3, and then I add my 1 numerator. So 3 times 1 is 3, plus 1 is 4, and I keep my same denominator. And I'm not going to touch this fraction yet, because that one was already written as just a single fraction. So now we have a new question that we can work with a lot easier because we don't have that mixed number in there. So we have 4/3 plus 2/5. They do not have the same denominator, so I need to find a common denominator. So I'm going to use what is called that butterfly technique that I showed you in the first one. To find the common denominator, I multiply 3 times 5 to give me a new denominator of 15. And then to adjust my numerators, I multiply the first numerator by 5 to give me 20. And I multiply the second numerator by 3. My cat is here trying to get in the way to give me 6. Okay, so you saw we multiplied 3 by 5 to get 15. So 4 by 5 gives me 20. 5 multiplied by 3 gives me 15. 2 multiplied by 3 gives me 6. And now this cat, get kitty, I can just add my numerators. 20 plus 6 gives me 26. And I keep my same denominator, 26 over 15. Now you'll see I do have an improper fraction here. I could change it back into a mixed number, just like we did up here. So I want to see how many times does 15 go into 26. It goes 1 time evenly, and that is 15. 15 times 1 is 15. So in order to get up to 26, then I have 11 left over. So I have 1 and 11 over 15 is how I could write that as an improper fraction. And I can do it over here. I say 15 goes into 26 1 time. 1 times 15 is 15. And when I subtract, I get 11 left over. So that becomes my new numerator, and I keep my same denominator. Next, we're going to look at subtracting fractions with unlike denominators. And subtracting fractions is the exact same method as adding fractions, except in the end, up here where we added our numerators, we're going to subtract our numerators. But everything else is going to be the same. We still need to find a common denominator when we subtract fractions. So here's my example, 3/4 minus a negative 1/3. So I have a denominator of 4 and 3. I want to find a common denominator, so I can use the butterfly technique. 3 times 4 can give me my new denominator of 12. It is still a subtraction question, so I'm still going to write that subtract in between. Now that I have changed both my denominators, I need to change my numerators to match. This denominator I multiplied by 3 to get 12. So I'm going to also multiply my numerator by 3 to get 9. This denominator I multiplied by 4 to get 12. So it means I'm going to multiply also my numerator by 4. -1 times 4 gives me -4. Don't forget your negative. A negative number multiplied by a positive number will give me a negative answer. So here are my new fractions that have the same denominator. 9 over 12 minus a negative 4 over 12. And now all I need to do is subtract. 9 take away negative 4. And this is where some people will get a little confused because we're still struggling with negative integers. 9 take away a negative 4. If I'm taking away something negative, means I'm getting actually more positive. Or we can think of it like I have said in class many times. Instead of subtracting, you can always add the opposite. So taking away a negative is actually the same as adding a positive. So now this becomes a lot easier. 9 plus 4 becomes 13. So 13 over 12 would be my answer. My denominator stays the same. 9 take away a negative 4 is 13. Now I could change this into a mixed number from an improper fraction. 12 goes into 13 one time with 1 left over. So 1 and 1/12 would be my answer. But this is also acceptable as an answer. So I want to do one more here, this time with a mixed number. So 2 and 1/3 take away 1/7. So just like our last example, we want to switch this mixed number into an improper fraction first. So before we worry about common denominators, first thing we need to do is just change this into an improper fraction. So 3 multiplied by 2 gives me 6, plus 1 gives me 7. And I keep my same denominator. And this fraction doesn't change yet. Now I can find my common denominator using the butterfly technique. 7 times 3 is 21. So both my denominators now change to 21. This denominator I multiplied by 7 to get 21. So I'm also going to multiply this numerator by 7 to get my new numerator of 49. This denominator I multiplied by 3 to get 21. So I'm going to multiply this numerator also by 3 to get a new numerator of 3. And now I have a common denominator, which will stay the same, and I can just subtract my numerators. 49 take away 3 gives me 46. And again, I can change this into a mixed number if I want. 21 goes into 46 2 whole times. And that would leave me, that's 42. And so it leaves me with 4 left over. So that would be my answer in mixed number form. But again, improper fraction is fine. Next, we're going to look at how we multiply fractions. Now, multiplying and dividing fractions are actually much easier than adding or subtracting fractions. And the reason for that is we don't need to find a common denominator when we multiply. No common denominator needed. So these are a lot faster to do. There's a lot less calculation involved. So I'm going to do the example 2/3 multiplied by 1/4. So all we need to do for multiplying fractions is multiply. We multiply our numerators, 2 times 1, which gives me 2. And we multiply our denominators, 3 times 4, which gives me 12. And that is my answer. Now I can reduce that because both of these numbers will divide by 2 evenly. So 2 divided by 2 is 1. 12 divided by 2 is 6. So I can reduce this to 1/6. And that's how you multiply fractions. We can try a -1 instead. We'll do the same fraction, except make one of them a negative number. So in that case, -2 times 1 becomes -2, and 3 times 4 is 12. And I can still reduce to -1/6. And here we're just using those rules for multiplying and dividing numbers. If you have a negative multiplied by a negative, it will give you a positive number. If you have a positive multiplied by a positive, it will also give you a positive number. But if you have a negative multiplied by a positive, it gives you a negative number. Basically, if your signs are the same, like in these, the answer is always positive. If your signs are different, the answer is always negative. So you just need to remember those rules, and that's only for multiplying and dividing numbers. So there you have it. Multiplying fractions, so easy, no common denominator needed. Just multiply straight across and just make sure that you are being aware of your rules for multiplying negative and positive integers. Finally, we have dividing fractions. For dividing fractions, we actually want to change our question into a multiply question. And we do that with 3 words. Keep, change, and flip. We're going to keep the first fraction the way that it is. We're going to change divide to multiply, and we're going to flip the second fraction upside down. So let's take a look at an example. Let's do that was the last question. We're going to do 5, 6 divide by 6 over 4. Okay, so we're going to keep my first fraction. So I'm going to write that down. 5, 6 is going to stay the same. We're going to keep it. We're going to change the divide to multiply. And we're going to flip our second fraction. So what once was 6 over 4 is now going to become 4 over 6. My denominator comes to the top. My numerator goes to the bottom. And now I have a multiplication question just like we did up here, where all we had to do was multiply the top numbers together and multiply the bottom numbers together. So we do that. 5 times 4 is 20. 6 times 6 is 36. So there I have an answer. Now I can reduce this because both of these numbers will divide by 4 evenly. 20 divided by 4 is 5. 36 divided by 4 is 9. And that's the lowest I can go. So whenever we're reducing, we're just trying to find any number that both of these can divide evenly by. So 20 can divide evenly by 2 and 4. 36 can also divide by 2 and 4, but we want to take the biggest number so that we only have to reduce once. So there's our answer, 5 over 9. Now let's do another example where we have some mixed numbers involved. So here we have 2 2/3 divide by 1 1/5. So just like all our other questions that we've been working on, we don't want to deal with mixed numbers. We want to change those into improper fractions first. So I'm going to do that first before I do anything. I'm not going to try to flip anything or change anything else. I'm just going to change these into improper fractions. So I take 3, multiply by 2, which gives me 6, and add 2 more, which gives me 8 over 3. I'm not going to change this. Now I'm going to change this into also an improper fraction. 5 times 1 is 5, plus 1 is 6. Keep my same denominator. So there, all I have done so far is change my mixed numbers into improper fractions. Now I can look at this as a brand new question, and I see that it's a division question, so I know that I need to do keep, change, flip. I need to change this into a multiplication question in order to proceed. So I keep my first fraction, I change my divide to multiply, and I flip my second fraction to 5 over 6. And now I just have a multiplication question. I multiply my numerators to get 40. I multiply my denominators to get 18. And that's my answer, although I can reduce it. I can divide both of these by 2 evenly. So I could get 20 out of 9. And I could even go further and change this back into a mixed number. Since I started with mixed numbers, I can change it back into a mixed number. 9 divides into 20 2 times, so that's my whole number, 2, which is 18, and I have 2 left over. So 2 whole times with 2 left over. So that would be my mixed number form. But again, this is fine as well. So that's how you would do dividing fractions. Change them first into multiplication questions and then just multiply as you would normally.